Welcome back to the Packet Lab. Today we're taking a look at another OSPF lesson, and today's lesson is going to concentrate on the OSPF interface level area assignment. So when you're running OSPF, each interface needs to be assigned to an OSPF area, and there's actually two ways to accomplish this. In this lesson we're going to take a look at the interface level command, which is IP OSPF area. There's another lesson that looks at accomplishing the same task using an OSPF routing process level command, which is the network area command. I would strongly suggest that you go back and view that lesson before you take a look at this lesson, because it's going to give you a lot of the concepts that I'm not going to deep dive into here, and it's also going to allow you to compare and contrast the benefits and differences between these two commands. The OSPF IP OSPF area interface level command is going to allow you to assign an interface to a single OSPF area. It's going to give you the advantage of configuring OSPF area on an interface by interface basis, and that's going to be different than the routing process level network area command, because what that command does is it creates a range of IP addresses, and it looks at each interface and says, oh, do you match this range? If you do, then you are assigned to this particular area. This lets you go under each interface and say, okay, this interface is assigned to area 0, for instance. One of the benefits of this is that if you happen to re-IP your interface, the area assignment doesn't change. Now we'll look at that in detail a little bit later, but that can be a benefit, I guess, or a curse depending on what you want to happen here. But it's different than how the network area, basically IP range, works. Another advantage is you're not creating a range, so you're not going to have to deal with creating a network address and wildcard bits for a range. It's a pretty cut and dried command. You go under the interface and say, hey, this is the OSPF process I want to use, and this is the area that I want to assign. So it's a little less complicated than the network area command can be. One thing I should state right now is that these are not mutually exclusive commands. You can run these together. In a lot of cases you will, depending on the number of interfaces you have on your device. You might use both. I'm starting to see a lot more use of this interface level command rather than the network area command, but again, it depends on the number of interfaces and what you want to accomplish. One potential stumbling block with this command is that it requires a newer iOS version, and newer is relative. If it's older than 12.3.11, then it may not be available. Not many production devices should be running 12.3.11 or older code, so it's probably going to be available. But again, it's not available, then you will have to use the network area command. And I'll say this for the last time, I strongly suggest that you go back and view that lesson. So here's our command reference. This is just cut and pasted from the Cisco documentation. If you're looking at this and you're seeing references to OSPF v2, that's basically the OSPF that you're going to be running if you're running IPv4. If you're running IPv6, you'll be running OSPF v3, but that is outside the scope of this lesson. So anyways, this first sentence we can just forget about, because that's basically describing how the network area command works. It says here you can enable OSPF v2 explicitly on an interface with the IP OSPF area command that is entered in interface configuration mode. Yuppers. This capability simplifies the configuration of unnumbered interfaces with different areas. Okay, well, we're not going to get into true unnumbered interfaces here. Basically, how you can read this is that it doesn't matter what the IP address is. The OSPF area assignment is for the interface and not specific to the IP. So as we'll see later, you can change the IP address when you're using this command, and you'll still be assigned to the same area. All right, and this last paragraph here is just saying that if you're running both the IP OSPF area interface level command and a network area which matches the IP address on the interface that you've configured this IP OSPF area command on, and they have different area assignments, say that the network area is saying, okay, this interface should be in area 0, and the IP OSPF area statement is saying, no, it should be in area 1. The IP OSPF area statement is going to supersede the network area command. So this is when you're running both of these at the same time, and it's actually can be used to your advantage. We'll see this later, that you can have a network area statement that encompasses a number of interfaces. Then, if you want different areas for particular interfaces, then you go under those particular interfaces and assign them a different area with the IP OSPF area command. But in a war between IP OSPF area and network area, IP OSPF area is going to win, and we'll see this in action a little bit later. Right, so here we're in the configuration mode, and we're actually in interface configuration mode. The way that we can tell this is we see this config-if, which stands for interface configuration mode. So this can throw you off a little bit if you're not familiar with the structure of this command. So you issue IP OSPF, and then you invoke the Cisco IOS help with the question mark. And you can see here you get quite a bit of output here, but none of it says area. So the first argument that you have to supply for this command is the process ID, and that's why this is in red right here. And this can trip you up. We'll see this a little bit later on, that when you specify the process ID, if that process does not exist, like say that you have no OSPF configuration on your device whatsoever, and we specify IP OSPF process 1, it'll actually create that process 1 in the running configuration, and you'll be able to see that when you show the running configuration. You're going to want to make sure that you have the correct process ID, because what can happen is if you're already running a process, say you're running process 1 and you accidentally put in IP OSPF process 2 here, it's going to create process 2. And you assign your interface to a specific area, everything's going to look golden, except you're going to have two processes running. And without going too deep into OSPF processes, they don't matter when you're communicating between routers, but on the router itself, it is locally significant. You can basically split up your OSPF routes by assigning them to different processes, and that's what's going to happen here. Everything will probably look good. You'll get a neighbor relationship, with another router, because it's not going to care about the process ID, but the routes aren't going to be shared between processes, and it can get ugly. So this is one of the big stumbling blocks. Make sure that you have the correct process. Once you specify the process, then you can go ahead and invoke the Cisco iOS help once again with the question mark, and then you're going to have to type in the word area and then assign the appropriate area based on your design. Now, if you invoke the help again, you can see that there is an additional argument, which is secondaries, and we'll take a look at that later. That's secondary IP addresses, which is one of my least favorite things in the Cisco world, but we'll touch on that later. So you could basically just go ahead and hit enter here. So our command is IP OSPF process 1 area 0. So now we've assigned, well, I guess it didn't give you the interface, it's interface 00/1 to area 0 in OSPF process 1. So now if we use our verification commands, we can do a show IP OSPF interface, and we're going to just specify 00/1 here. You can see here that the IP address of the interface has now been assigned to area 0. And what's really cool is it's going to show you enabled by interface config. That means that we have assigned this area on this interface using the IP OSPF area command. If you have used a network area command under the routing process, this whole line will not show up. And the second bit of this will come into play later when we get into the dreaded secondary IP addresses, and it says including secondary IP addresses. And I'll tell you right now what that means is it's going to advertise any secondary IP addresses assigned to 00/1. We'll see this in a little bit more detail later. So here's that potential pitfall that I showed you. It can be a boon or a bust, depending on whether you get the process right or wrong. So if the OSPF routing process is not already created, this command will create that process for you. So here we're doing a show IP protocol summary, and these are the three dogs that will be running by default on your router: connected, static, and ODR, as I like to call it, odor. I think that's on-demand routing. Nobody uses in production, so don't worry about that. Anyways, we go into the interface, and we're under interface 00/0, and we're going to assign this interface to area 0 in process 1. So now, once that's done, if we go back and, well, if we were to do a show IP protocol summary, we would see a number 3 here and OSPF. If we do a show run section router OSPF, remember there was no OSPF configuration before. The only line that we put in here is this IP OSPF 1 area 0, which is under the interface. We now have OSPF process 1 configured, and this log adjacency changes may or may not show up in your particular configuration. That's a default command. So this is pretty sweet, unless you fat finger it. So let's assume that we've created the correct area assignment for 00/0. Let's say that we go under 00/1 and we want to assign this to area 0 as well. And we type in IP OSPF, and instead of 1, we accidentally type 2 area 0. Everything's going to look good when we do our show run running configuration, and we take a look at the router OSPF processes. And I said processes plural because we're going to see two of these. We're going to see the router OSPF 1, and then we're going to see router OSPF 2, and probably that log adjacency changes. Again, without going too deep into this, you've created separate processes, so now those routes aren't shared between those processes. This can really screw you up in production and in a lab, especially if you're sitting in the CCIE lab and you fat finger. You could have a whole lot of troubleshooting trying to track this down. So again, for the last time, I'll emphasize that you do want to make sure that you get this process correct. Okay, and as I said, you can run both the interface level IP OSPF area command and the routing process level network area command at the same time on the same device. This particular slide is going to show you the battle the clash of the titans, if you will, between these two commands. So on R2, if we do a show run and we're just going to take a look at our existing OSPF process, see we have process 1 and we have a network area statement that is saying 10.1.23.2, and this quad zeros means match this exactly. So basically what we're saying with this statement, if you don't understand this, like I said, go back and check out that lesson. We go through this in excruciating detail. What it's saying is I'm going to match this exact IP address. If there's an interface that has this exact IP address, I'm going to assign it to area 0, and lo and behold, 00/1 does have this exact IP address, so we have assigned it to area 0, right? Well, if we take a look at 00/1, we also have IP OSPF, and same process, making sure we got the process right, and we have assigned this to area 23. So now we have two commands that are both addressing this interface, and they're assigning it to two separate OSPF areas. So which one's gonna win? Well, we already blew the secret here with the output down here. Plus I told you that the IP OSPF area interface level command is going to take precedence over the network area or routing process command. And we can verify this with our show IP OSPF interface brief command. You can see here that 00/1 with 10.1.23.2 as its IP address has been assigned to area 23 rather than area 0. And as I mentioned earlier, one of the advantages of the IP OSPF area interface command is that you can re-IP the interface and retain the same OSPF area assignment. Again, this could be a boon or a bust depending on how you are wanting to change your topology. If you want to keep the same OSPF area, then it's great. If you want to change it, well then you'll have to remember to change your IP OSPF area command to reflect the new area. If you do want to maintain the same OSPF area, then this does have an advantage over the network area command. So here we see on router 1 that we have two network statements. This first statement is going to match 10.1.12.1 exactly. So it's going to find an interface that has this IP address and assign it to area 1. This next statement is the catch-all. It says all interfaces be assigned to area 2. So if you went through the lesson on the network area command, you know that it's going to take these in order specificity, and it's going to assign area 1 to this IP address, and then anything else will be assigned to area 2. And we see this in action when we issue our show IP OSPF interface brief command. We have two interfaces on this router, and you can see here because this one has an exact match for this network statement, it's going to be assigned to area 1. Since this one is not an exact match, it just gets assigned to area 2 because that's where everything else is being assigned. So now changes come to your network and you're told to re-IP 00/0, and you go in and you change the IP address, and you don't pay a whole lot of attention to the OSPF area assignment. Let's say in this case that you wanted to maintain area 1. It's just the IP addresses that are changing. So if you don't pay attention to this, what's happening now when you do a show IP OSPF interface brief is that both of these interfaces are now in area 2. And the reason why that is because you've changed this IP address. So iOS looks at these network area statements. So it says, okay, well, my IP address of 100.1.12.1 does not match this statement, so I'm not even going to worry about that. It does match this statement, so I'm going to go ahead and assign it to area 2. So in this case, your OSPF area changed along with the IP address, because when you change the IP address, you put it into a different network area range assigned to a different area. So keep that in mind when you're re-IPing. Now, if we go through that same scenario, but we use the interface level IP OSPF area command, we'll see a difference in behavior. So here we go, and we're back to normal. We reset this. Instead of using network area commands to assign our OSPF area, we're using the IP OSPF area command under the interface. So take a look at 00/0. You can see it's got the 10.1.12.1 IP address, and we've also assigned it to area 1 in OSPF process 1 with the IP OSPF area command. We do a show IP OSPF interface brief, and booyah, it verifies what I just told you. Now we go under the interface and we change the IP address to that 100.1.12.1. We don't make any other configuration changes. Now we go ahead and issue our show IP OSPF interface brief. We've changed the IP address, but we're still in area 1. That's the important takeaway here, is that this command assigns an OSPF area to an interface, regardless of what the IP address is. You can change that IP address all day long. It will still remain in area 1 for OSPF process 1. If you want that area to change, then you'll have to go ahead and reissue this command with the new area. But a lot of times, if you're not changing areas, and honestly in OSPF designs, you probably wouldn't be changing it too often. This does allow you to re-IP without having to go muck around with network area commands. All right, secondary IP addresses. Janky, fucking janky. That's all I gotta say. One of my least favorite features of iOS is the secondary IP addresses, but I will refrain from ranting any further about this. If you've got them configured, you're gonna want to know how the IP OSPF area command addresses them. So if we take a look at 00/0, you can see here that we have an IP address of 10.1.12.1, and we also have a secondary IP address of 100.1.12.1. Without going too deep into what secondary addresses are, and yes, I did say addresses as in plural because you could have multiples here. Joy. What it's going to do is it's going to allow traffic destined for 10.1.12.1 to go to 00/0, as well as traffic destined for 100.1.12.1 to the same interface. It's, like I said, janky, and it is really fun to play with this when you're running dynamic routing protocols because of the way that they handle this. In this case, we are going to issue the IP OSPF area command, and we're going to assign this interface to area 0. Now remember, this is an interface level command. When you're using the network area command, it's not going to bother with secondary IP addresses. It's going to only address the primary IP address. This is a little different. It's going to actually assign both IP addresses to area 0. Now, the difference being that the primary IP address will be used to establish OSPF neighbors and do all the good stuff that OSPF does. The only thing it's really going to do with the secondary IP address is just advertise it into OSPF. So this is one of the few times where show IP OSPF interface brief doesn't give you a good look into this, because it's going to just show you the interface and then the primary IP address and then the area assignment. If we do a show IP OSPF interface, in this case, we're going to specify the interface, which is 00/0. It's going to give us more information and actually tell us how this is working in the background. So it shows us the primary IP address and says that's assigned to area 0. Does not list any of the secondary IP addresses, but what it does tell you is this is enabled by interface config, and we know that that means that we use this command, booyah. And it says here, including secondary IP addresses. What that means is that it is going to advertise any secondary IP addresses on this interface into OSPF. Doesn't really give you that in so many words, but that's what this means. And the takeaway here is that this is the default action because we didn't do anything special with this command. We didn't specify advertise the secondaries. So if this is what you want to happen, this is what's going to happen. Keep that in mind, because if you don't want this to happen, we'll show you the next slide how to prevent this. But the way we can verify this is I go to another router and I'm getting OSPF routes on that router. And you can see here that the 100.1.12/24 range is being advertised. And you can see here it's actually learning it from router 2 in this case. What happened is this secondary IP address is advertised into OSPF. And with OSPF, it's going to be advertised into area 0. So the LSA type 1 and 2s will show up for this network. So now let's say that you don't want this to happen, and we'll have to go to a different slide to show you how to do that. Okay, same setup as before. This time when I issue my IP OSPF area command, I'm going to specify the area, which is area 0. Then I'm going to enter the word secondaries, and I'm going to put argument in of none. And what this is going to do is this is going to disable the advertisement of the secondary IP addresses into OSPF. Once again, show IP OSPF interface brief. Although you're my dog and I love you so much, you don't really help out here. So we're going to do a show IP OSPF interface, specify the interface. Same as before, primary interface is assigned to area 0. No surprise, enabled by the interface configuration. Yep, we done did that. And here's what we're looking for, excluding secondary IP addresses. So by default, it includes secondary IP addresses. When you add this argument of secondary none, it excludes them. So now if we go to router 3 and we do a show IP OSPF route, we are not seeing the secondary IP addresses, which if you remember was 100.1.12.0/24. So that's the way that you prevent these from being advertised into your OSPF area. Depending on what your design is, and God, if you've got secondary IP addresses, you better revisit that design. You can control whether these are advertised or not. All right, so we're going to do a little CLI action here, and this is a topology we're going to use. So we've got a triangle of routers, all connected with a single serial interface using the IP addressing range that I am fond of using, which is from router 1 to router 2. We're going to use the 10.1.12.0/24, the .13 and the .23 and the third octet for the connections between 1 and 3 and 2 and 3 respectively. We do have loopback interfaces configured on each of these guys, and they're going to be the quad of the router. So for router 1, it's going to be quad 1/32. Router 2 is going to be quad 2/32. You get the idea. And you see our area assignment. So we're going to assign the connection between R1 and R2, as well as R1 and R3 to area 0. And then the connection between R2 and R3 is going to be assigned to area 23. And then each of the loopbacks are going to be assigned to an area based on their router. So loopback 0 on router 1 will be assigned to area 1, be assigned to area 2 on router 2, and you get the idea. So let's jump onto the CLI and start putting this IP OSPF area interface level command through its paces. Alright, so we're on the CLI, we're over on R1. Let's go ahead and take a look at the interface assignments here to show IP interface brief. I'm going to exclude anything that is unassigned, and you can see our IP addressing scheme here. It'll be pretty familiar to anybody who's seen my lessons before. So let's get to it. Let's get into configuration mode, and first of all, let's go ahead and do a do show IP protocol, and you can see we don't have any dynamic protocols running. We do add a sum for summary on the end of that. You can see what we do have running. We have connected, static, and ODR, which are the three which will be running just by default. So the important takeaway from that is that we don't have anything currently configured for OSPF. So what we're going to do is we're going to go under the interface for 00/0. Let's go ahead and do a show run int s0/0 just to show you what's on there, and nothing configured. So let's go ahead and do IP OSPF. And when you're configuring OSPF under the interface, every command, I believe, I can't think of one that doesn't, will start with IP OSPF. Let's use our friend Cisco iOS help, and you can see here we get quite a bit of output here. There's a lot of different options for this. The thing is, you don't see anything that says area, so that's the first kind of stumbling block here. You're going to have to know that for this command that the next argument it needs is the process ID. Now, we haven't set up OSPF routing on here at all, so we could choose any process ID that we want. We're going to keep it simple, just go with 1. Now when we invoke help, we're going to see that the next argument is area, so we have to type that in, and we can put the area in our normal integer form, or we can put it in as a dotted decimal if we want to be fancy. We're going to go ahead and assign this interface to area 0, and we'll try help one last time here. And you can see here there's one more argument for secondaries. We'll take a look at that a little bit later, and we did discuss that on the slides, but right now we can hit enter. So now let's go ahead and do show IP protocols summary, and booyah, we're running OSPF process 1. So we could verify that by doing do show run. Let's do a do show IP OSPF interface brief, and there we go. So we can see here that serial 0/0 is in process ID 1. It's assigned to area 0, and here is the interface. So you get a lot of good information from your show IP OSPF interface brief. You'll notice that we have process ID 1, but we never configured that. All we did was put in that interface level command. So we do show run, and then we're going to grep for router OSPF. You can see here that there is an OSPF process. So when you use this interface level command, if you do not have the process created, it will go ahead and create it for you. And like I said, the stumbling block with that is that you want to make sure that you get the right process ID, because if you were to put in the wrong process ID, and I'll show you that a little bit later, but if you put in the wrong process ID, it'll create a separate process, and that can create some bad juju for you. Alright, so quick pop back over to the topology. So we see now that the next two interfaces that we have to configure are this loopback into area 1, and then we'll go ahead and put the second serial link into area 0 as well. So let's get back on the CLI, and we do that with inst s0/1, and we can just go ahead and put IP OSPF 1 area 0. Easy peasy lemon squeezy. Now for the loopback interface, we'll go ahead and do the same thing. This is going to be in area 1, and I always like to use my show IP OSPF interface brief to verify the OSPF assignments, and you can see here we're looking good because we've got them all in process ID 1, and then we have the two serial interfaces in area 0, and then the loopback interface in area 1. And we never had to go under the routing process to do this. We did this all at the interface level. So let's pop on over to R2 and start configuring away on that one as well. Okay, on R2 we're going to do things a little bit differently here. We're going to go under the router process, and we're going to use process 1, and we're actually going to issue a couple of network area commands. So again, if you haven't seen that lesson, please go ahead and watch that one. Before I do that, let's go do show IP int brief, exclude ass. Okay, so we can see what is assigned here. And what I'm going to do is I'm going to create a network statement, and I'm going to specify 00/1, and I'm going to give it the quad zeros. And I'm going to assign it to area, I don't know, 69. Delicious. And then I'm going to go ahead and create a default area assignment and make that area 2. So now if I do a do show int brief, IP OSPF int brief. Yeah, I was afraid of that. Because we don't have anything in area 0 and we do have a neighbor that's in area 0, we're going to get this error message for a little bit here, so just bear with me. But what I'm looking for here is that we have everything in process ID 1. It's going to keep moving up the screen. Sorry about that. And what we got here is 00/1 is in area 69, the other one's on area 2, and the reason that is because we specified to put this one in area 69, and the other ones fell into what is basically the default network area assignment. So let's go ahead under interface 00/0 quickly here and go IP OSPF 1 area 0. That should stop that message now too. So what it's actually done is it's created a neighbor relationship between R1 and R2 on that interface. So if we do a show IP int, OSPF int brief, you can see here now that 00/0 is in area 0. And the reason I did this is to show you is a battle between the interface level command and the network area statement. The interface level command is going to win because 00/0, if you remember up here, was assigned to area 2 because it was matching, if you go way back up here, this network area command, which is basically match everything. So it was assigned to area 2. When we went under the interface and we specified that it be assigned to area 0, it overruled that network area assignment. So that's who's going to win in a battle between those two, and you can use that to your advantage. So right now we have one interface, 00/0, which was assigned with the IP OSPF area interface level command, and the remaining interfaces, loopback 0 and 00/1, were both assigned their area via a network area statement under the routing process. So if I go ahead and do a do show, I'll just up arrow, make it easy, do show IP OSPF interface, we're going to get a bunch of output here. Let's take a look at 00/0 first. You can see here it's got the IP address and the area. Now that's the one that we manually configured, and here's the line that we're looking for. Enabled by interface configuration, including secondary IP addresses. So that's telling us that when we assigned the OSPF area for this interface, we did it with the interface level configuration, and basically we use the default. Now if I go down to, I don't think the loopback will show it. Actually, we're looking for evidence by lack of output here. I'm not sure if the loopbacks contain this or not, but definitely 00/1, we can see here that we don't have that line here. So when we don't have that line that says enabled by interface config, that means that it was assigned by the network area statement. We can also do a do show IP protocols, and we're only running OSPF on here. If you're running multiple protocols, you'd want to when I say protocols, I'm talking about dynamic routing protocols. You'd want to grep just for the OSPF. In this case, OSPF is the only dynamic routing protocol we're running, so we're safe with just using this command without filtering any further. And it's going to give us all of our OSPF information. And here's what I'm looking for here. If you watched the last lesson on the network area statement, you would know that this is actually your running configuration, sans the network keyword at the beginning of this. So these are your network area statements in the order that they are showing up in OSPF, which is in order specificity. And then here we can see which ones that we assigned via the interface level command, and that's just 00/0 at this point. Under the loopback, let's go ahead and assign this to, process 1, area 2, and then serial 0/0, right? I'm sorry, 0/1, and assign that guy to area 23. So that's how you make mistakes. Anywho, so now let's go ahead and reapply our show IP protocols command. And you can see here, we still have those network area statements, but now we've got 3 statements here, and it's showing up 3 different times because it's showing up once for each area. So it's telling you that under area 0, we explicitly configured 00/0. Under area 2, we explicitly configured loopback 0. And under area 23, we configured 00/1. All of these using the IP OSPF area interface level command. So now if we do show IP OSPF interface brief, well, what do you think is going to happen? Because we still have these network statements, remember? And they're saying, okay, I've got some assignments for area 2 and area 69. And actually, area 2 isn't going to matter so much here because it's a loopback. You can see here that area 69 does not get assigned at all, but I guess that's not surprising because that was the quote-unquote host area statement there. Anywho, basically all three of these guys are being assigned by their interface level command. And again, I'll beat the hell out of a dead horse here and just tell you that that does override your network area statements. And then finally R3, and we don't have anything configured here. This is fresh out of the box. Booyah. Let's go ahead and get in configuration mode. I'm going to go under the interface 00/0. This is a connection to R1, so this should be in area 0. So do an IP OSPF 1 for the process area 0. Do show IP was int brief, and you can see we assigned it correctly, and we also get the added bonus because it has now formed a neighbor with area 1. If we were to do show IP OSPF neighbor, there's router 1. So now let's go under interface 00/1. Now this is a connection over to router 2, and this should be in area 23. So let's go ahead and assign it to area 23. Cool. Hey, look at that, and we got a neighbor relationship. So now if we go ahead and reissue our do show IP OSPF neighbor, everything's looking golden. We're cooking with bacon here, right? Did you guys notice the mistake I made? What's wrong with this command? So that first number there, that 2, that's the argument for the process ID. So now if I do a do show IP OSPF int brief, there's our assignments. Everything looks good, you know, we're in the right areas. This is going to bite us in the butt. So you can see here that 00/0 is in process 1 and 00/1 is in process 2. If we go do show run section router OSPF, we're going to end up seeing 2 different OSPF processes that have been configured, because when we specify the process ID, if that process has not been created, it will go ahead and create it for you. Now I'm not going to get too deep into how the OSPF process works. That's for a different lesson here, but basically these guys are not going to share routes with each other. They're going to be separate processes. Not going to be a big problem in this case because it's all going to end up in the routing table. If I was to do a do show IP route OSPF, not router, OSPF, all of our routes are here. It's just that we're learning some of them on process 1 and some on process 2, so we can separate those. But there is a separation of routes, and this would be a problem in not so much in our topologies because we have everything connected. I'm going further into this than I really should. Just the takeaway is watch that you don't fat finger that. So now if we go under the interface, well, we're still there, but I'll make sure that we explicitly show you that we're under interface 00/1. Do IP OSPF 1, that's process 1 area 23. It's going to change that. So now it's going to actually drop our neighbor relationship because we changed the process. We're still in the same area, but it's actually really a different area because it's a combination process and area. And now if we go ahead and reissue our do show IP OSPF interface brief, everything's in process 1. But what do you think? If I take a look at the running configuration, what am I going to see? Well, before we do that, let's do a show IP protocols. Now we're only running OSPF, so we will only get output for OSPF. Let's see what it has here. Well, this is interesting. This is different than what we had before. We've got, you know, our first process here, and we can see everything's been enabled explicitly. We're not using any network area statements. But this little bugger, I thought we got rid of that. We didn't, and we can prove this by doing a show run, including the router OSPF processes. And you can see here that process 2 and 1, ebony and ivory, side by side on my piano keyboard. Oh Lord, why can't we? Anywho, to get rid of this, pretty easy. You probably want to not be under interface configuration mode, but then you just do a no router OSPF 2. And now if we go ahead and issue that same command, what comes back should just be router OSPF process 1, and we're golden. All right, before we get out of here, let's go ahead and complete our configuration by putting the loop back into area 3. Do show IP OSPF int brief, and there you go. Our assignments are rocking. Let's break out of configuration mode, and real quickly, if you want to see the configuration, we can reverse engineer that from the show IP protocols. And for this router, it's going to be pretty easy because we're going to see that all 3 of these interfaces were explicitly assigned. So if we had to reverse engineer the configuration, we would have to say, oh, okay, interface 00/0 is assigned to OSPF process 1, and then it's been assigned to area 0 within that process. Loopback 0 is also in process 1, area 3. You get the idea. So one of the things with the IP OSPF area interface command is that verifying in the running configuration isn't as easy. If you were to do a do show, I'm sorry, you don't need a do here because we're not in configuration right now. If you do show run section router OSPF, and we've shown you this, well, section router will work too because that's the only protocol we're running. We basically have nothing under this process. This log adjacency changes is just a default that gets thrown in there. With the network area command, if you were to issue that command, you would see all the network area ranges. So you'd be able to see all the configuration there. So if you want to do this for the IP OSPF area command, you'd have to do a show run, include inter for interface, and then I would just grep also for OSPF. Actually, that's going to grab everything. IP OSPF. Kind of an ugly command. Basically, it's saying here is show me the running configuration, but I only want to see the bits that either include the characters INTER, all lowercase, this is case sensitive, or it's that second grep here, IP space OSPF. Hit enter. It's going to take a little bit to think about this. I guess the takeaway from all this is just it's not as easy to, show all your configuration for the interface level commands as it is for the routing process commands. Anyways, you get the output that you need here. It's going to give us all the interfaces regardless if they've been configured for OSPF or not. So I guess that's the quick and dirty for that. All right, well, let's go ahead, and what we're going to do is we're going to explore how this command works with secondary IP addresses. I hate secondary IP addresses. I think I've made that abundantly clear. Let's go on R1 under 00/0, and what we're going to do is we're going to add another IP address, and we're going to use 100.1.12.1, 255.255.255.0, and let's see what help tells us here. Oh, look at that. We get the option for secondary. Wonderful. And that's all you need to do. So now if you do a do show run int s0/0, we have a primary interface IP address of 10.1.12.1, and we have a secondary of 100.1.12.1. And we are assigning this interface to IP OSPF 1 area 0, so process 1 area 0. So let's go ahead and do a do show IP OSPF interface 00/0. Let's do brief first. Like I said in the slide portion, this is where show IP OSPF interface brief kind of falls down a bit because it's showing us 00/0. It's saying, okay, you're in process 1, you're assigned to area 0. That's all true. Here's your IP address. I don't see anything for that secondary IP address, and it's not going to show up. What we can do here, though, what we're really interested in is taking a look at the interface, and we'll just specify 00/0 directly. Here you go. Here's your primary interface and your area assignment. Yeah, we know that we went and did this under the interface configuration, and this is what you're gonna get, and this is a default. Regardless if we have a secondary IP address on here or not, this is going to be the default. What this is telling us is that by default, when I use this command to enable OSPF on this interface and assign it to an area, I'm going to go ahead and advertise out the secondary IP addresses. And the way we can verify that is if we pop over to R3, for example, do a show IP route, and we just want to see the OSPF route. So if we specify OSPF at the end of this for that last argument, we should only see the OSPF routes, which basically are going to be the only routes that we have. And right there, you can see here that we have the 100.1.12.0/24 is being learned in this case from R1. So we are advertising that secondary IP address. So let's go back over to R1 and let's say, okay, in our design, for whatever reason, somebody was drinking heavily. They did want to have secondary IP addresses on this interface, but we don't want them advertised out. So how are we going to stop that? We can go into some advanced filtering. Filtering in OSPF is pretty interesting, but that's a topic for another day. Really what we want to do is on the interface level, just say, hey, please don't advertise this out. And how we do that is we're still under 00/0. I'll just do it just to make sure that I'm not fooling you guys, and B, more importantly, I didn't fuck up and put this under a different interface. So if we issue IP OSPF process 1 area 0, and you remember from earlier we have that secondaries option here, and when we do this, this means we're going to go ahead and disable it. So now, give me a little space here, go ahead and up arrow. Let's take a look at 00/0. Everything looks the same except for here. It's now saying excluding secondary IP addresses. Ooh. So let's pop on over to R3, up arrow, let's see our routes here, and take a look at this. you'll notice a difference between what we had before and what we have now. And that difference is that the secondary IP address from R100/0 is no longer present. So that's how you stop the advertisement of secondary IP addresses with this command. So if you're running secondaries, this might be important to you. One important takeaway is that by default, it will advertise those out. So if you don't want that to happen, you're going to need to go in and use this secondary none argument. All right, one last thing, and we're done with the CLI here. Let's go ahead, and this is on R2, and what I'm going to do is I'm going to go under interface 00/1 and remove this IP OSPF area assignment. So no IP OSPF 1 area, in this case it's 23. Let's do show run int s0/1. That's going to break our neighbor relationship. That's fine. We're probably going to see a bunch of output here when we get into this. What I want to show you here is that this no longer has the interface level area assignment. But if we do a do show IP OSPF interface brief, it is assigned. It's assigned to area 69. And the reason that it is if we do show run, fat fingered. Well, let's just go ahead and take a look, see if we can, wow, I must have broken out of it. Anyways, let's go ahead and redo that. Section router OSPF. Okay, so the reason it's assigned to area 69 is because we have this network area statement, which is matching it exactly. And then we also have a default, which would assign it to area 2. So let's say we're going to do a little bit of network change here, and we're going to re-IP these guys. So what we're going to do is under interface 00/1, we're going to go ahead and give this an IP address of 100.1.203.255.255.255.0. We've changed the IP address, but we wanted to keep the same OSPF area assignment, in this case area 69. So let's go ahead and do show IP int brief, IP OS int brief. Spaghettios. You can see here that we have changed the IP address. So we did that part right, but now we're in area 2 instead of area 69. Well, why is that? Well, if we remember back up here, it's going to assign this specific IP address, any interface that has this specific IP address, to area 69, and it's going to say, well, anything else, go ahead and assign to area 2. So that's what's happening here, is we're no longer matching. This 100.1.23.2 does not match this 10.1.23.2. So it's going to go ahead and say, oh, well, this line does not apply to me. Let me see what the next line is. The next line says, oh, go ahead and assign everything to area 2. So this is important to keep in mind when you're using the network area statements, that when you re-IP, you may need to change your network area statements to make sure that your area assignment is correct. But you see, it didn't throw up any fireworks and tell us, hey, you know, you're changing from area 69 to area 2, which is kind of surprising. I thought it would do that. But anywho, so let's go ahead and do the same thing under interface 00/0. And let's do a do show run int s0/0 first. You can see here, in this case, we've assigned it to area 0 with the IP OSPF area command. So let's go ahead and, change the IP address to 100.1.12.1. Let's see what happens here. We're probably going to get a bunch of errors, yeah, because we're going to lose this neighbor relationship. Actually, we won't get errors because it's not on the same IP subnet. I'm babbling. So the big important takeaway here is that we've changed the IP address. So now if we go do show IP OSPF interface brief and we take a look at our interface assignment, well, serial 0/0 did not change its area. It's still in area 0, even though the IP address did change. And the reason for that is this command is specific to the interface. It doesn't give a good goddamn what you use for an IP address. It's saying whatever IP address you have configured under this interface, I'm going to assign it to OSPF process 1 area 0. So change away, re-IP to your little heart's content. So that's a difference, and that is an advantage, or it could be a disadvantage, depending on how you want your OSPF area assignment to be when you change this IP address. But it's good to keep this in mind. All right, that's going to do it for the CLI. Let's jump back into the slides now. And here's our verification commands. We saw these on the CLI quite a few times, actually. So if you do a show IP OSPF interface, and you can always specify the particular interface, it's going to show you the interface, the IP address, which is going to be the primary IP address if you're running secondaries, and then the area assignment. And then down here, if you have used the IP OSPF area command under the interface, it's going to show you that it's been enabled by that command, This is a good thing to know, especially if you're on an exam, Cisco exam. They might use this in a question to have you reverse engineer the configuration, and because you were paying attention, you know that if it says enable by interface config, that means that the IP OSPF area command was used under the interface, including secondary IP addresses. As we saw here, that is a default. If you want to turn that off, you have to issue the secondaries none argument. And then down here, same thing, but you can see here, what did we do differently here? We just talked about it right there. Excluding secondary IP addresses. So again, if you got this on an exam, you'd know that not only did we enable this at the interface level, but we also must have provided the secondaries none argument. And like I said, this is one of the few cases where the show IP OSPF interface is going to beat out my buddy, the show IP OSPF interface brief, because it's going to give you that information about how it is handling the secondaries, as well as if you want to know whether this was assigned an OSPF area via the network statement or if it was by the interface level IP OSPF area statement. Those last few examples notwithstanding, this is still my dog. This is a show IP OSPF interface brief. I like this because it gives you all the stuff that you really need when you're troubleshooting in a table format, and we've seen this guy endless times. Real quick, it shows you the interface, the process ID, the area that's assigned to, the IP address, and then the cost, which we're not dealing with today, and a couple other things. But this is the one command with OSPF that I use over and over again. And as always, you can do a show run to see your running configuration to show you how you have your OSPF area assignment set up. I showed you a little bit of a grep that you could use there just to get the interfaces. You can also do that to capture the router process, as well as we saw endless times on the CLI. I'll go through this real quick because this is showing you the show IP protocols command, and if you're running multiple dynamic routing protocols, you probably want to grep for just the section that is OSPF. It's going to show you how your OSPF area assignments are being administered, and if it says routing for networks, it's going to give you this range here. Basically, you can just put the keyword network in front of that, and that's what's going to be in the configuration. So that's going to be your network area statement under the routing process, and then it's going to give you for each area, it's going to tell you routing on interfaces configured explicitly, and then it's going to tell you the interfaces. So that's going to show you that on those interfaces, we went under the interfaces and explicitly issued the IP OSPF area command to assign our OSPF area. And we're at the summary, which you know is the last slide. Yay! Alright, so each interface running OSPF needs to be assigned to an OSPF area. There's two ways to do that, and we've actually looked at both of those today. As I said, ad nauseum, and I'll say at least one more time, I do have a lesson on the network area routing process command. I would suggest that you go view that. Today we took a look specifically at the IP OSPF area interface level command, but we saw both of these guys in action when we were on the CLI and how they interact with each other. So the IP OSPF area interface level command is configured under the surprise interface. So this gives you the advantage that you can go under each interface and explicitly assign it to an area. You can use this in combination with the network area statements, or you can use it exclusively. It's probably going to depend on the number of interfaces that you have. If you have a device that has a ton of interfaces that you have running OSPF, you're probably going to want to use the network area statement, because the power of that is that you can specify a range and with as few as one statement assign every single interface to an area. Whereas if you're using the IP OSPF area command under the interfaces, you have to go under each interface and configure it. So whichever method suits your device better, go ahead and use that. It's good to know both of these. One thing to keep in mind is that you will need to have a quote-unquote newer version of iOS, and like I said, 12.3.11 is the version. If you got something older than that, you're not going to be able to use this IP OSPF area command. Shouldn't be a lot of production stuff out there running that older code, but you might run across that. So a couple advantages of the IP OSPF area interface command is that it will override an existing network area OSPF assignment. So you can use these, like I said, in combination, where you have network area statements that are assigned interfaces, and you go in and just onesie twosie specify a different area for these under the interface. It will override that network area statement. We saw that on the CLI. The other advantage, and again, whether this is an advantage or not depends on what you want the final result to be, is that it's going to assign an OSPF area to the interface regardless of what the IP address is. So you can re-IP to your heart's content. It will still be assigned to that particular area. That can be a blessing or a curse depending on what you want the ultimate configuration to be. Probably the biggest gotcha with this command is that when you're issuing the IP OSPF area command, you have to give it an argument for the OSPF process. If you don't don't have that process created, iOS will do this for you. It will go ahead and create that process. So if you had a fresh out of the box router and you went under interface and said IP OSPF 1, now that's going to be the process, area 0, it's going to create OSPF process 1 for you. Great, that's awesome. The problem is that if you fat finger or you put the wrong OSPF process in there, it's going to go ahead and create that for you as well. And that could create a problem in your network if you already had an existing process, because now you're going to have multiple processes running there and they're not going to play nicely with each other. And it's a bear to troubleshoot this because everything can look normal. You have your neighbor adjacencies. You just have a router out there that has decided to split the routes. Anywho, that's a lesson for a different day. The takeaway here is be careful when you're putting in your OSPF process because it will create that for you. You want to make sure you get that correct. And this last line here we've gone over already. If you have a network area statement that matches an interface's IP address, and under that interface you also issue the IP OSPF area command, IP OSPF area will emerge from that battle victorious. All right, thanks once again for joining me in the Packet Lab, and as always, I hope this helps you on your route to becoming a network god.